So here's a cool idea. Usually we have the wire straight like this, right? But what if we went ahead? Instead of going ahead and just putting it straight, why don't we just go ahead and make it into a loop? Just like this one. Okay, you see that this actually will change things with our magnetic field. And even if you think about the right-hand rule, we can see some effect. So I'm going to just put a magnet right outside this loop. I'm going to go ahead and tap the battery. And you can see the magnet will point that way. You see, even if I stay in here. Now outside the loop, see if we can get it. It'll actually point the opposite direction. This kind of makes sense if you think about the right-hand rule, but only for this loop. Think about this, right? Having coming out the positive end of the battery, okay? And you're looping around, but as you loop around, you notice your hand is going to have everything still going the same direction, okay? And all these field lines are going to clump up right here. And eventually you have something, as you see it going outside, if we do the right-hand rule, it's coming out of the page. In other words, this rocket's heading right towards you, right here, okay? So we're going to have things coming out of the page. So we're going to have a bunch of dots, and they're all going to clump up right here, and they're going to be strong. And outside the loop, we're going to have a bunch of X's on either side. Okay? And if you're thinking about this, right, you're going to go ahead and get this magnet shape again, where basically you have everything kind of clumping up like that. And basically you're getting this loop going out through the center and around and coming back, just like a normal magnet would. So it'll be like this, coming out and back in. And it's actually kind of a cool idea to think about. So I really want you to think about this in terms of the right-hand rule. And there's also an equation to go along with this, which I'll introduce in the next slide.